Your application is suddenly getting more traffic. Do you add more pods or just giving existing pods more CPU and memory? That's the auto-scaling question every DevOps engineer faces. In this video, we are doing a complete deep dive into Kubernetes Autoscaling, the Horizontal Pod Scaler and the Vertical Pod Autoscaler. By the end, you will not only understand how they work, but you will see how it works in a real-world scenarios. So let's start with the basic. What is autoscaling? Autoscaling automatically adjusts your application resources based on demand. Without it, you either over-provision, that is wasting of money, or under-provision, that is crashing under the load. Autoscaling keeps our application stable and cost efficient. So Kubernetes gives us three types of autoscaler. First is Horizontal Pod Autoscaler, which adds or removes the pods. Vertical Pod Autoscaler, which adjusts CPU and memory for existing pods. And the Cluster Autoscaler, which adds or removes the nodes. So in this demo, we are going to cover HPA and VPA. We were going to cover in another video. There is two prerequisites for this. First is the metric server should be installed, which will be used to collect usage data. Another is we should be aware about the resource request and limits, and it should be defined in our deployment file. So I've already covered the resource request and limits in very much detail in my earlier video. So I will add a link in the I button and in the description. So I would suggest you to check it out so that you can get a better understanding of resource request and limits and this auto scaling concept as well. Okay, with that foundation in place, let's start with the most common one, that is the Horizontal Pod Autoscaler. HPA works by monitoring metrics like CPU and memory utilization, then automatically increasing and decreasing the number of pods to maintain a target utilization. In real world example, imagine a shopping app during Black Friday. The traffic spikes like crazy. HPA scales from 2 pods to 10 automatically, then scales back down after the sale. So first of all, we need to install the metric server so that HPA has a data. Because without metric server, HPA has no data. We won't be able to autoscale our application. So this is my Kubernetes cluster. So kubectl get nodes. So this is a one node cluster, and in this the metric server is already installed. And to verify that, we can run kubectl get pod -n kube-system. And if we see metric server here, so this is the pod which is running a metric server. But if you're running a Kubernetes cluster with vanilla or some different flavor, so you need to install the metric server in your system. So this command will be used for that. Don't worry, I will add this thing in the description as well. So this command will automatically install the metric server in your system. So I already have a metric server running. So let's create a simple deployment to test the HPA in action. We will use an Nginx container, but the key here is to define resource request and limits, because that's what HPA monitored to decide the scaling. So let me create one file, that is hpa-deploy.yml. So this is my deployment file, and this is the same structure which we follow in our earlier videos as well. And this is the resource request and limit. So HPA looks at the request like 100 millicore and to decide when to scale. So apply this. So kubectl apply -f hpa-deploy.yml. So the deployment got created. So kubectl get deploy, and we can see the deployment is in the running state. And if we see kubectl get pod, we can see our pod is also running. So this creates one Nginx pod for us. So now let's create a HPA using the kubectl command. So for that we can use kubectl autoscale deployment or deploy. We can use any keyword here, and the deployment name, which is HPA-demo. And here I am specifying the CPU percentage -CPU %, equal to 50. If an average CPU across pod goes above 50% of the request, it scale up the pod. So after that, I am going to use -min, that is minimum, equal to 1, that at least keep one pod running. And then I have a max, that is maximum pods allowed. So I'm specifying 5 here. So now the HPA got created. So let's run the kubectl get HPA. So this is the one. Run this again. Now we can see the metrics which is coming from the metric server, so that the HPA will get to know about this particular usage of the CPU. Now test the HPA by generating a load to our pod. So for that, let me run one pod kubectl run -it -rm pod name load -generator, and I'm using the image that is busybox, and I'm running a command here /bin/sh -c, and I'm running a while loop here while true, and doing the wget to -q -o http/hpa-demo, and done. So this command starts a temporary busybox pod that continuously hits our Nginx pod and generating a CPU load to it. So let me run this. I think there is a syntax error in this, so let me run it again. So we are getting a bad address from the HPA pod. I think I missed one step, that is to create a service, because our application is not been exposed yet. For that I need to create a service resource. So let me do it very quickly. So let me run the kubectl command, kubectl expose deploy HPA-demo. Let me show, I missed the port, -port equal to 80 and -target port equal to 80, and let me specify the name, that is HPA-demo. The service got created, so kubectl get service. So our HP-demo service is running, and if I hit the same command again, so this time it's working fine. If I run kubectl get HPA, and let me run it with the -w. So as you can see, CPU consumption got moved to 22. Right now it's not exceeded or test the 50%. That's why I didn't create another pod for that. Now it's 58. So this time it should create a pod. Let me duplicate the tab and enter the password here. And if I run kubectl get pod, and we can see the new pod got created with the HPA-demo. Now the load is 53 because it created 2 replicas of that pod. As the load increases, it creates a pod, and if the load decreases, it scales down the load. If I run this command again, so it's still running with the 2 pods, and this is our load generator one. So now the HP have scaled it to the 2 pods, and the CPU consumption is not getting beyond the 50%. It got stuck to the 29%. So suddenly if the load slows down, like let me cancel this now. So this time the load will decrease because I turn off that particular container, like the load generation one. It is not running now. So it should come to 0 and should delete the pod which is being created by the HPA. As we can see, it's decreasing the load to 3% now. So after some time it will come to 0 as well, and at that time it will delete the pod. As you can see, it's 0 now, and it should delete the pod which is being created by the Horizontal Pod Autoscaler. So it will wait at least of 5 minutes because HP is having a stabilization windows before deciding when to lower the pod. So right now the CPU consumption is 0%, but still the pod is not being deleted because I think it will wait for the downscale stabilization window, which is generally a 5 minutes. So that means the HP wants CPU to be consistently below target, that is 50%, for about 5 minutes straight before it removes the pod. If your load generator stopped recently and HP saw these values, that is these are the recent improvement, not the stable for the whole window. So HP will observe it for a while. If it stays low consistently, then only it will remove the pod. Now if you see, the load got to 0% for more than 5 minutes, and if we come here, the pod got terminated as well because the task got completed for that is to manage the load. And right now it's only having one pod which is running with the HP-demo, and if I run kubectl get pod here, we can see only one pod is running. And if I run the kubectl get HPA, so the CPU consumption is 0% for more than like 5 or 10 minutes. That is passing the stabilization window. So that's why HPA deleted the pod, because there is no spike in the CPU utilization. So HP is all about scaling out your application. If your pods start getting busy, HP adds more replicas. If your workload becomes idle, HP scale them back down. It's perfect for stateless applications like web servers, APIs, and anything driven by traffic patterns or CPU or memory spike. So HPA scales pod automatically, and it uses the metric server to track the CPU and memory. And you can also control the target percentage and the minimum and maximum replicas using the kubectl command. So if I show you kubectl autoscale, using this command we can control the threshold limit, minimum and maximum replicas. And it's great for auto-scaling microservices, APIs and the front end. So you don't need to touch pod resource manually. HPA watches your cluster and adjusts for you. And in the next video, we are going deeper into the other side of auto-scaling, where instead of increasing pods, Kubernetes increases resource requests. There's the vertical pod autoscaler. It's a game changer for heavy machine learning workloads, batch jobs, databases, and anything where scaling out doesn't help. If this helped you understand autoscaling better, hit the like button and subscribe for more content like this. Thanks for watching. I will see you in the next one.